Good morning, everyone. How's everyone doing? Good? All right. Yes. My name is Jamie. I hail from Detroit, Michigan in the States, and I'm running on about 3 hours of sleep over the last 30 minutes. And it's entirely my fault. I had a layover in Paris, and I put my passport in my bag. Got to customs. I was like, oh, I'm going to make this because my flight leaving Detroit was late. I only had an hour layover in Paris. And I get up to customs and I was like, oh, I got my passport. And I pulled out my field notes 48-page memo book, which is not my passport, nor does this work. So I missed my flight. Anyway, got here, got on time. We're here. So thank you for coming. We're going to talk about WebSockets and APIs and Elixir. Who's here for the Elixir content? All right. There's not much Elixir content here, so I'm happy that you are here for that. I am also giving an Elixir workshop tomorrow if you're interested in Elixir. Okay, so this talk is based on my experience building a real-time WebSocket API with a friend of mine, and building this over the past year and a half. And this talk kind of summarizes all the findings that we found. So if you're looking to build a real-time WebSocket API, this may have some of your answers for you. I'm not really on Twitter anymore these days for obvious reasons, but you can find me there sometimes when I need my fix, or you can find me on GitHub at Wright. If you don't do the Twitter thing, there's my email address. Also, this talk is online, so there's going to be a lot of code in this talk, so if you guys want a copy of this code, it is here, or you can go to speakerdeck.com/jwright and you will find it there. Okay, a little bit about some background, how we got here. I wanted to build an enhanced Pomodoro application. If you guys are not familiar with Pomodoro applications, basically it's how I need to work. It's how I've worked for the past couple decades. I suffer from ADD, so I need like little spurts of work followed by some breaks. So that's what a Pomodoro is. It's 25 minutes of work followed by a 5-minute break, and you repeat those cycles every day. And that's how I work. And I've tried every single Pomodoro app out there, tried physical timers, everything, and they all lack something that I want. So a buddy and I sent out to build Chronic. It's at chronic.io if you're into Pomodoro apps. It's not live yet. And it's going to be called Chronic until Dr. Dre sues us, maybe. Okay, this is the wonderful, well, it's not anymore, but this is the wonderful UI that we were working with. And the reason it's so hideous is because we didn't care about this UI right now. We just wanted a test harness to kind of test our API in. And the idea is we wanted to build, that's not supposed to, yeah. We wanted to build an application that had a lot of, that worked on all platforms. So you didn't have to be at your desk when you used it. So we wanted a desktop app, a mobile app, Amazon app, Echo app, Slack app. It's probably the worst idea ever, but we wanted to try it. So because of that, we had a few, this is what led us to WebSockets. We wanted the server to actually be the timer. The server is the gold copy. And then the server pushes events to the clients. And then all the clients need to do, because we wanted many of them, all they had to do was display the events on that payload. And I'm going to show you, the other reason was we wanted to integrate with several integrations. We wanted integrations with timekeeping apps so that we could automatically log our time after the Pomodoro was up. We wanted Spotify integration so you could, if you're pairing with somebody on the same Pomodoro, You could listen to the same music, same stuff like that. So we have all these integrations planned, and these events need to happen in real time. We need to know where the Spotify time sync is so that we can give your partner on their Pomodoro the same sort of experience. Okay, here's a quick little demo. This is a horrible UI. But here it is in mobile, and all I have down there, I'm going to let this play through a couple times. But I just have the web inspector down below, and you'll see events come through. You'll see a started event and then a tick event. And then every tick event, has the payload of what that time is. So it's not like we started a JavaScript timer and we're just counting down from there and pushing it back to the server. We're going the other way. Okay, and we're going to get into that payload and all that in a little bit. Okay, so in order to make this all work, we need to know about WebSockets. But what the hell is a WebSocket? Well, we went to go find out because I heard about them. I didn't know fully what they are. So the first thing a WebSocket is a protocol. Okay, a protocol. It's a full duplex connection. And what that means is it's similar to if you think of HTML, or it's a full duplex connection, and both sides can chat at the same time. So I can chat, and the server can chat, and the client can chat, and nobody gets interrupted. If you compare that with HTTP protocol, that is a simplex connection, meaning one side can chat and the other side can respond. One side can chat and the other side can respond. So I liken that to a walkie-talkie. So WebSocket's more of a phone call conversation. A WebSocket or HTTP more like a walkie-talkie. The other thing that came out of that protocol is this RFC, and this RFC was created in December of 2011, and the RFC is just request for comments. It's like a proposal, hey, this is what we think WebSocket should look like. And out of that came the W3C spec. Now, this originally was bundled in with like the HTML5 spec, but because that became gigantic, they broke it out, CSS WebSockets, and all that into this W3C spec. And what you got from that is that browsers support a WebSocket object in JavaScript. And basically how it works, it's a pretty simple object. You give it a WebSocket URL that starts with ws:// instead of HTTP. It has 3 callbacks on open, so when the socket gets open, when you get a message, so any sort of data that comes by, you get an on message callback, and the data is inside that event args. And then you get an on close. So if the client or the server closes the connection, you will get that callback. And then if you want to send something from the client to the server, there's a send. And if the client wants to close the connection, there's a close. Pretty simple, right? But the cool thing with WebSockets is this part, I think. It starts with a handshake via HTTP. So the server starts off, or the client starts off and does a GET request, and with the header of upgrade WebSocket. So that's all that looks like. And then underneath, the server says, okay, can I support this version of WebSockets? What are some other plugins that this WebSocket needs? Do I have all those? If that is great, the server sends back on HTTP 101 switching protocols with a connection upgrade header. And then, this is the best slide of the whole thing. So the cool thing is the single connection, the single TCP connection starts out as HTTP and then gets converted into WebSockets, which is cool. That's how it gets around proxies and firewalls and all that stuff. You don't need any special, installs on your browsers, anything like that. I think that's cool. So We chose WebSockets because they're more real time. We don't have to wait for a response. We can just fire and forget. It's very eventful. So WebSockets have fire off of events. Our server fires off events. Everything is based on an event. And that's really nice in the architecture of the code, has it on both the client and the server. Okay, so that's why we chose WebSockets for the clients. The server, we chose Phoenix. Now, Phoenix is the web framework for Elixir. It's the Rails to Ruby. It's the ASP.NET to .NET. And it was originally actually built around WebSockets. It was originally a library for simply WebSockets before it became a full-blown HTTP or HTML MVC framework. So it supports WebSockets out of the box. It's a very WebSocket-friendly framework. It has a lot of templates that build up to have those WebSockets built in. And it's built on Elixir. If you're not familiar with Elixir, Elixir is a fairly new language, I guess. I can't say that anymore. I used to say that back in before the pandemic. But it was built in 2011 was when it first started. It was released in 2012. And is built on the Erlang virtual machine. The Erlang virtual machine is older. It's from the 90s. It was built by Ericsson. And Elixir takes advantage of Erlang's virtual machine. So it compiles down into Erlang bytecode, and it runs on the Erlang virtual machine. And it's if you have ever looked at Erlang, it's not so developer happiness friendly. Elixir comes from Jose Villim, who's from the Ruby community, so it's got Ruby-like syntax, but it's functional. And it's very, very fast. I'm not coming from the Ruby world. I wasn't used to all this fastness, but it's nice. And it's very concurrent, and it's stateful. So there's a cool feature of Erlang called the OTP, which is the Open Telecom Protocol. And this was built by Ericsson, like I said, and it needed to, what it is processes, tiny little Elixir processes, not like what you would think of normal threaded processes, but these are Elixir processes. They're really, they're Erlang processes. They're really fast to spin up, and they can talk to each other. So you can have like all these little black boxes that are, that can send and receive messages. So our timers are all OTP processes. So anytime you start up a process, that timer starts in an OTP process. So every user has a timer, which is nice because then if it fails, it only affects that one user. OTP is also, it has this idea of hot code reloading. So you can actually deploy code without losing the OTP process in the process of deploying, which is nice because every time we deployed, all the users would lose their timers, which is not a good thing. So there's a way to deploy in Phoenix with no downtime, which is amazing. These WebSocket APIs, we went and took some inspiration from others that have done this before, and I want to call out. Slack has well, they don't really support this anymore, but they used to have a real-time library that you could send and receive messages from. In a channel, you can receive team events, receive user presence, so if a user left or came back, and those are all things that we wanted our app to have. Pusher, if you're familiar with Pusher, allows you to kind of build these APIs using a service, that they have their own service, so you don't have to worry about the server side of uptime and things. So they have some really good docs. And there's another API called GetStream that just has a read-only API. That's really nice if you like building like a timeline type feature, and you want to always update your timeline with real time. information. So how does this work? So let's look at some code. Okay, the first thing that a client needs to do in our API is connect, right? And we want to control that WebSocket address. We don't want to go to our docs and say, and have people say, hey, put in ws:/chronic.io/whatever. We want to give that to people so that, you know, Dr. Dre sues us, we can change the URL, or whatever. We need more capacity, we can change that URL. So we built a GraphQL API on top of that, where you can, there's a mutation, and you called connect, and what you do, the client sends to the server. Oh, sorry. Yeah. Okay. So that's just a regular GraphQL endpoint, and the server sends back a token for authentication and a URL. That then the client needs to use that as a WebSocket URL. So this gives clients a starting point. They always know how to connect to your service. It's a way to identify events that come from that. So when a client connects, we take a fingerprint of the device that they're using, or the agent that they're using, and that's how we know what user is using what devices. And this is a good opportunity to authenticate. So if a user cannot authenticate, if they cannot connect, you don't need to give them any information. So I'd highly suggest everybody have this in their API, kind of a regular REST or GraphQL API endpoint. Okay, so this is some JavaScript code, some simplified JavaScript code of how we connect on the client side using GraphQL client. And then once we get this URL, we put that into the WebSocket, and now we can use our WebSocket just like normal. This is the test that we wrote for the server side. So we're going to do a little TDD on the Elixir side. Elixir comes with, I'm going to explain this Elixir code a little bit for those that are not familiar. But Elixir comes with a testing framework called XUnit. And Elixir is functional. So there is no state. You have to pass the state through functions to transform that state, and you get a new state out. And so in functional language, in Elixir, a module, you can think of it like a class, but it's not a class. It's not an object because it doesn't have any state. So modules are just collection of functions in Elixir. And so this module is a test module. This describe is some special DSL stuff that is basically a method. And so here we're connecting in the test, and we're getting the last connection. So we have a database called connection where we just hold the tokens and the URLs for the users. And so we just want to ensure that that gets created when a user connects. And this is the simple connect on the server side. So this is using, in Phoenix, there's a GraphQL library that is slipping my mind right now. Absinthe, thank you. Absinthe, it's awesome. It's like, I've used several GraphQL libraries. It's amazing. It's really, really nice. But these are just a resolver. So for your mutations, you just have resolver. So all we do is connect here, and this connection.create down here is really the heart of it all. In Elixir, a pattern that is followed in this case statements. So it's calling this create down here with the user. And that connection.create is going to return a tuple, either an OK tuple or an error tuple. And if it's an error tuple, you're going to have the errors that are not making that valid. Or if it's OK, then you'll get that connection back. And that's a standard pattern that is followed in Elixir using these tuples, followed by these little braces, you see. And then this in Phoenix is the WebSocket integration. So anytime you create a new Phoenix project, you get this Phoenix socket module, and it has channels, which we're going to get into next. And then you have a connect function that this supports. So when a user connects to your server, it'll call this. And this is actually creating an OTP process behind the scenes. So every connection, every WebSocket connection in Phoenix is an OTP process, which is pretty cool. So all this is doing is assigning some state to that WebSocket. And it's assigning the token that the user got. This is the token that we use to identify the user. All right, let's talk about channels. All right, so what are channels? Channels are not like a thing. They're not like a W3C spec. They're not like a standardized thing. It's a custom protocol that's built into Phoenix, actually. And it's multiplex. It allows you a single connection to talk to multiple different clients. It allows things like pub sub. So when the client or server publish a message, somebody else can subscribe to and receive those messages. And in Phoenix, it's like I said, it's built in. And to be honest, we didn't want this. We didn't want this in Phoenix. Phoenix comes with a JavaScript library as well that you can load on the client. That you can see that it says socket here. Not WebSocket, it says socket. That is a Phoenix socket. And it just wraps a regular JavaScript WebSocket, but it gives you this channel stuff. And so when a user first connects to a socket, the first thing that they have to do is join a channel. And we just have one channel defined that has all the events for that given user. Okay? I'm not going to get into this too much, but this is how the server handles the channels. I'm going to tell you why I'm not getting into this, but basically there's a subscribe and join function that assigns that user to that WebSocket, that OTP process in Phoenix. And this is a channel, an event. This is in Phoenix, there's these things called channels that you can just create. So we only have one channel called the event channel. And when somebody uses it, this join and events, and then you see this crazy little, operator there that can actually take out the token. So it's events : and then the user's token. But in Elixir, you can actually take that out in the definition. And so it's going to be put into that token variable. And so all we're going to do is look for that connection for that token and then just assign that token back to the channel. If the user's not authorized for that, like if we don't find that token, then we don't allow them to join that channel. Okay, the problem with channels. This is a real picture on the internet, by the way, I found. So the problem is, because it's a custom protocol in Phoenix, we didn't want our clients to have to say, okay, now you have to send this phx_join event, and because we didn't want people to know that's Phoenix, and you can't change that. It's stuck at phx join. and then the server comes back and gives the client the payload. Because that's so custom and it doesn't follow the rest of our WebSocket API flow, which you'll see in a little bit, we didn't want it this way. So if you are doing WebSockets in Phoenix, you can do this as well, so that you don't have to have channels. But we wanted to remove the complicated setup from clients. This does, in Phoenix, provide some functionality. There's a reconnection logic. There's a heartbeat logic to make sure that the WebSocket connection doesn't disconnect. Because if a WebSocket does not see any traffic after a time limit, it'll close. And this is not, it's easy to do, but it's not straightforward to do. So if you're interested in doing something like this, there's, I put the code out there to kind of remove channels from Elixir. So, all right, messages. So these are the messages that are sent to and from our API, and we wanted these to be very well defined because this is the meat of our API. And so what we came up with was this kind of shape of message where you have an event name inside of an array and then followed by event data. The event name we wanted to have like a model and an action. So all the events are some sort of noun followed by a verb. And we timestamp everything, every message that comes through, we timestamp because you want to add metrics to those. So incoming messages. These are messages that are coming from the server to the client. So this handle on start click is just some JavaScript handler. However you do this in your JavaScript, you know, if you're using React, then you would have this as an on-start click, which is what we're using on our client. So all we're doing is when they click start, the play button on the timer, we just send a timer start. We give it the duration in seconds. So this is 25 minutes, 1,500 seconds. And we give it a timestamp. And that's what that looks like to the server. And the server comes in, and this is the test that we made for it. So we already inserted this connection that the user, you know, previously connected with us over the GraphQL API. And like I said, all the timers are OTP processes. So we want to make sure that that OTP process received the message to start the timer. And we just want, this system timer is the timer, the countdown timer that is running on the server. And it's an OTP process, and we're just getting a status of that, and we want to make sure that it is running. So how we actually implement that is we have this module, timers events, and on the receive, Elixir supports something called pattern matching. Other languages have this. I think .NET is getting it or has it now. I'm not sure. But it is the coolest feature ever. All it allows you to do is really redefine the same method over, but give it a different signature based on the data that's coming in. So you can have multiple receive events with the timer start is, it could be something different. So we want to make sure that we get this message, and we want to make sure that we have a duration. So if neither of those match, Elixir will just bomb out and say, hey, we don't have a function to call for you. And so that's kind of like a way to defend against, you know, bad data. And so all we do is we call this system timer.start. We give it duration, And this FN state is, we'll get back to that. But every time there's a tick message that happens, every time there's a second countdown, we broadcast that tick message within there. Then we get a response. So basically, we have a wrapper around our API that gets the state of that system timer as it is. Like how many seconds are left, or how many seconds did you start with, what's the ID of that timer, all that stuff. And that gets sent back to the client. And so the client would get that message, which is an outgoing message. So these are messages that the client gets, and they follow the same pattern, except we wanted the client to get kind of the past. We use kind of the past notation of the verb that matches the verb that the client sent in. And this data that's below is all the data that's from the actual OTP process. This doesn't hit the database at all. All this information is stored in that OTP process. Okay, so this is what happens on the client when they get a message from the server. So we look for the timer's started event here, and all we do is like change the update the view. So we change it from a play button to a pause button because it's now running. The state is now running. We change the seconds, start counting the seconds down, all that stuff. And we just do it kind of inside there where I'm console logging it. Okay, so broadcasting a tick event. I'm sorry, this is broadcasting the actual timer started event. So when the OTP process receives a timer start, we want to make sure that we return a timer started event. Yes. So this is the same code as before, then the receive for timer start, except I filled in the function for click there. So every time we get a click, we broadcast to that ID for that user that their timer is ticked. So if that user is connected on their iPhone and connected on their Mac, they will see the exact same times ticking down. Okay, so we connected, and we just use regular HTTP and GraphQL. We use GraphQL. Feel free to use REST or whatever you're comfortable with, although GraphQL is awesome. And then we send back, then the server sends back that URL and a token for the user that identifies that user. Then the client sends to the server, they'll send a timer start event for the duration. And then the WebSocket will send back, hey, I got the message, the timer started. Here is all the data associated with your timer. So that, I want to reserve a lot of time for questions. Yeah. Does anybody have any questions on the actual implementation or maybe details that they would have of their own implementation? That questions? Yes.
Can you tell me a bit about Elixir ecosystem of programming? Tools, debugging?
Yes. Yeah, so the question is around the Elixir ecosystem. Okay. The Elixir ecosystem is really vibrant right now. So in terms of tooling, you know, everybody uses Phoenix for the web framework stuff. There's several hosts that will support the hot code reloading. There's a host called Gig Elixir, so that will support the hot code reloading. There's also a really good Elixir host, pass host called fly.io, and they're really nice because they'll put their actual Elixir code near your users. However, they can't do that and support hot code reloading. So if you don't need hot code reloading, then that's an amazing choice. And then recently, Elixir has been getting into the AI space, trying to I think what they're doing is kind of trying to pry away users from Python and start using Elixir. So they've released a lot of new stuff that's kind of amazing. There's a numerical Elixir, NX, which supports running complex mathematical queries on the GPU for AI stuff. They released a thing called Livebook, which is a programming notebook, which is really helpful. You'll see it if you go in the workshop tomorrow, use Livebook. And they released Bumblebee, which allows you to take models, AI models from Hugging Face and other places and actually run those inside of Elixir. And there's a demo where he's just using Livebook. There's actually a demo from Chris McCord, the creator of Phoenix, who brings in Whisper. He puts in a podcast, brings in Whisper model, does live transcripts right within Phoenix, and I think it takes 15 minutes. So, like, the ecosystem around Elixir is very, very vibrant. Yes, I can say. Did I answer your question? Is there any other ecosystem things?
Oh, more like VS Code tooling or?
No, there's language server stuff. So VS Code, it has Elixir plugins for all that. I'm a Vim user, so I don't really know, sorry, anything else. But there's no real like code editor that like the Elixir community uses. A lot of VS Code, a lot of Vim, Emacs. Yes. So, you have a question?
Yeah, restarts. How are you resilient to restarts?
Yes. That is, there is some logic around both the client side and the server side around restarts. The cool, and we just basically ripped out the code that Phoenix does with the connection, reconnecting kind of stuff in the WebSocket world. On the server side, Elixir has this philosophy of like let it fail. And the reason is like OTP, those OTP processes can and will fail, but there's a supervisor that you can build above that will watch if these shut down. They'll tell other parts of the system that they'll shut down. They can shut down nodes that are close next to them or their parents. All this stuff that's really easily configurable. So when a node fails, it'll just come back up and we rehydrate that with stuff from the database. So that's really the only time we touch the database is when we need to sync the state, which we do every now and then, and then when we rehydrate the processes. So reconnects are pretty resilient in the system so far that we have. Did I answer your question? Yeah. Yes.
With the frameworks here, do you need to consider out-of-order message received?
Yeah. So the question is, do we need to worry about out-of-order messages being received either on the client and server? I don't know, because we don't care, because the next message will just have the new time, if that makes sense. So, like we're not building like, a banking system. The other thing is though, we do timestamp everything. So there, you can worry about that, but I don't have any sort of tooling or tracing to find out if that is happening in our system. Good question though. Because I know that will and can happen based on how you're architecting your system, especially in non-functional. I could see it happening in Ruby a lot. So yeah, it's probably something you need to defend against. Any other questions? Yes.
When it comes to WebSocket support, are there either clients or networks that won't support it, that you won't be able to interface with?
I'm not sure about the Amazon Alexa stuff because we didn't build that yet. But iPhone, Android, no, we haven't really found a client that doesn't support it. Slack does.
Are there network issues where firewalls can block it or that kind of thing?
Not that we have found. I have seen WebSockets being blocked on other applications when I'm like connected to hotel Wi-Fi or things like that. I've seen like packet drops and things like that, but yeah, I haven't ran like we don't have any users that are like, hey, I can't connect. So yes.
In the title, there was the real-time WebSockets APIs. But what you have been talking about has been mostly on the second time scale with ticks going quite slowly. Can you comment on making your read time with shorter ticks?
So the question, I don't know if I'm understanding your question. So the fact that we send ticks every second, like can it support a lower or a higher frequency of messages?
Yeah,
Yeah.
those kind of considerations.
Yeah, there's other messages, like we don't just send one every second to users. And we have tested this, actually, the throughput using Blaze. But it's nothing like spectacular in terms of throughput, kind of what you would expect. But we do send other messages to other services, and we get messages from other services. So we kind of do support that. We're not just sending every message every second. So, but I don't know I don't know, besides that, I can't comment on timing or anything like that. That was just based on my experience. Any other questions? Yes.
I imagine you have quite long-running connections. How is your experience keeping your connections open for
Long, yeah.
a long time?
Yes. Reconnecting it was kind of a pain to deal with. The reason being is like when your iPhone goes to sleep or they close the app out or they just switch apps, you lose your connection then. You can lose your connection and web clients if, HTTP goes out or if your connection goes out. So yes, you do have to support a lot of reconnect. Oh, heartbeat logic as well. Where there's heartbeat logic in the client so it sends a heartbeat message to the server that the server just ignores. It just needs to happen to keep that connection open. I think I want to say 30 seconds. I could be completely wrong. But the default on how long a WebSocket keeps its connection open is something like that. So you do have to have some sort of heartbeat logic in your WebSocket connections. And then reconnecting, if the user has that token, we can identify that user and get them back to the state that they were in. If we lose their token on the client side, then we kind of just log them out and say sorry, and they have to relog in. So yeah, that's how we deal with it. Any other questions? Yes.
When you start a long-running timer, will that be accurate down to, say, the millisecond, or is that not important for your?
It's not. It won't be because we only send back the seconds up to the second. But yes, we did a lot of testing around making sure that what it is saying on the client is kind of consistent across all the devices, and you can kind of see like, things switching exactly the same time is pretty cool on the web and mobile and things like that. So besides like those kinds of tests, was it spotting tests? Like, yeah, And we don't care about millisecond, like down to a millisecond. So, yes.
Do you support like multiple server instances, and how do you sync the?
Not yet.
No.
Not yet. So the good thing with Elixir is it's very easy to kind of do that. Nodes can talk to other nodes wherever they're at on the internet. So you can spin up a new instance. I have done that on other applications, not with WebSockets. So I can't comment on that. But I know that Elixir does support that pretty easily. And that was another decision why the fact that all the timers are just their own single OTP processes is because then those OTP processes can talk wherever they're at. Any other questions? Thank you guys for your time. I appreciate it. Enjoy the rest of your conference. Thank you.